Hey there, ladies and gentlemen, boys and girls. Today, we're going to do a little topic. We're going to do a little bit of a tougher one. We're going to build up everything we've done today, and we are going to move on from this idea of just all atoms or neutral atoms, and we're going to talk about the ion. All right? Little quick disclosure, two things real quick. Number one, as I kind of described this, I have a habit of giving atoms personification, the idea of giving atoms feelings and thoughts and stuff like that about being happy and sad. That's not actually true. Atoms are inanimate. They do not have feelings or emotions. I just do that to help convey an idea. And number two, what I'm going to show you guys right now is it's an interesting model that I like to use to kind of demonstrate it. It's not something you typically find like in a textbook or anything like that. It just helps visualize it here. I'm not asking you to do it every time. It just helps us get an understanding of what we do. All right. It might take you a couple times to do this video here. This is a tough one. All right. And I apologize ahead of time too. I got a little bit of the sniffles. All right. So first things first. First thing we have to understand is that most of the atoms on the periodic table, the way we've been doing it so far, are actually kind of unhappy. All right. The only ones that are right now that are based on what we've done up to this point that are happy are the noble gases in group 8A. And that is because the elements in group 8A have a full outer energy level. Something called the Octet Rule states that all atoms will gain or lose electrons to gain that full outer energy level. Every atom wants to look like a noble gas in terms of its electrons. Still going to have same number of protons. Fluorine, right, wants to keep its 9 protons, but it wants its electrons to look like neon, which is a noble gas. All right, so same thing with nitrogen. Nitrogen is going to keep 7 protons, but it wants to look like neon because it's its closest noble gas. All right, so I'm going to show you guys a little bit of how to do this and some of the thought processes that go through it. All right. This is just the way what I'm going to show here with a lot of pluses and minuses. It's just a way to think about it and to visualize what is happening. All right. So this is a little bit of a tougher topic. So here we go. All right. Let's do nitrogen. All right. Let's start with the idea of a neutral atom. Number of protons is equal to number of electrons. So nitrogen has 7 positive protons. Do some math. We're going to find it has 7 neutrons and 7 electrons to start. All right. So we draw our Bohr model. It's got 2 electrons on that level. And then it's got 3, 4, 5, 6, 7. It's got 5 valence electrons. All right. So let's take this now here. Right now, this nitrogen, he's unhappy. He's unhappy because he does not have a full outer energy level. He only has 1, 2, 3, 4, 5, when there can be 8 that fit in that energy level. All right. So now here's what I want to show you here. So I have my protons here. I have 7 protons. That's 7, 2, 3, 4, 5, 6, 7 positive charges. I have 7 positive charges here, which means I'm also going to have, for my electrons, I have 7 negative charges. Those aren't dashes, those are negative signs. All right? And then what I'm going to do with just the electrons, all right? Just the electrons. I'm going to draw a little line right between these two here. All right. I'm going to draw between the second and third one. And the reason why I'm doing that, all right, is because that second and third one there is because this would represent the electrons in the first energy level, and this would represent the electrons in the second energy level. All right. Now notice here, we are only talking about electrons. Octet Rule says they will gain or lose electrons for full outer energy level. I do not want to change the number of protons. Do not want to change the number of protons. That changes the element. I don't want to do that. I just want to change the number of electrons on the outside. All right. So This atom is unhappy because he only has 5 valence electrons when he really wants more, or he wants to have full outer energy level. He has 2 choices. All right? He can always gain or lose electrons. He's always going to do whatever's easier. By easier, I mean the lower number. All right? He can either gain 3 or more electrons to get 8, or he can lose 5 electrons. Okay. Whatever is easier in this case here, we are going to gain 3 more electrons. He's going to gain 1 here, here, and here. That means I gained 3 more electrons. 1, 2, 3. Gain 3 electrons. Right? When we did neutral atoms, we said if we had 5 positives and 5 negatives, they cancel each other out. So now I have positive and negative charges. All right? So I can say I have 1, 2, 3, 4, 5, 6, 7, right? Or a positive 7. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And as that full outer energy level, negative 10. Or I could just start canceling them out, right? I like to use a dry erase marker for this. So this positive and negative charge cancel each other out. Same as this one. This one, this one. These charges cancel each other out until I am just left with my extra 3 electrons. I am more negative now than I was at the beginning. All right? I am more negative at the beginning than I was at the beginning. So, or you could say that positive 7 and negative 10 is more negative. I have negative 3 more. Right? I have 3 extra electrons. So, this nitrogen atom, who is now has a full outer energy level, all right, he's happy, but he did that. He gained or lost electrons, and he formed what we call an ion. All right, so he has now become a nitrogen ion. More specifically, he is now nitrogen minus 3. Where did I get that minus 3? Is because I am more negative than I am positive at this point. I am more negative than I am positive. I have more negative signs than I do positive signs. All right? Because I gained 3 electrons. That's where a lot of people get thrown off, is that we think gain, so this must be a positive, because gain means positive. But what we gained is a negative electron. We are now more negative. We are now more negative than before. So now I have an ion, all right, that is a negative 3. More specifically, a negative ion is called an anion. I'm running out of colors here that I can use. All right, this is called an anion. Notice it's got the word ion in it. An means negative. This is a negative ion. Negative ion, negative ion. All right. That was a little tricky. All right, let's try another example. Let's try a smaller atom here. Let's try beryllium. All right. Let's start by drawing the Bohr model. Beryllium has 3 protons. Do the math. It's 4 neutrons. And start with a neutral atom. 3 electrons. Let me fix that there. It's a little bit better. All right. So let's start. 2 on the first energy level. Start, I have 1 valence electron. All right. So let's start with setting up our protons and neutrons, just thinking about those charges. 1, 2, 3 positive protons. 1, 2, 3 negative electrons. I'm going to draw that line to separate that first and second energy level. All right. Okay, so we have to make another choice. He is unhappy right now. That second energy level can hold 8 electrons. It only has 1. So he has 2 options. He can gain or lose electrons. To get to 8, he has 2 options. You can either gain 7 more electrons, that sounds like a lot of work, or he can lose 1. He can lose 1 electron. Ooh. Make sure you guys can see that. There we go. Or he can lose 1 electron. He's going to do whatever's easier. All right? He's going to lose this electron. He lost that electron. So if you want to do it kind of the math way, you could say, okay, he's going to lose this electron. Where it goes, we'll talk about that later. He leaves. All right? You're saying, well, wait a moment. How does that have full outer energy level? You literally have nothing in there. Well, it's gone. That electron's gone. There's nothing in that energy level. That energy level doesn't even exist anymore because there's no more electrons in there. There's no more electrons gone. There's nothing else in here. So we really got rid of that. What we did is we got rid of that energy level. And now we're down to its first energy level. And how many can fit in that first energy level? 2. How many are in there? 2. All right, which means that full energy level is full. Right now, beryllium is happy. But now let's look at the charge. All right. We basically have 3 positive protons. It's a +3. We have 2 negative electrons. Right? Because we just lost something negative, which means we are becoming less negative or more positive. All right. This is also a tricky one. We're losing something and becoming positive because what we lost is negative. That's tricky to kind of get your head around there. All right. So +3 and a -2 together make a +1. So this beryllium is now a beryllium ion. More specifically, it would be Be. I just realized I did lithium that whole time. It didn't stop me. Now that you could, it's a video. All right. That's all right. Okay, sorry, the video might be a little choppy. I made a mistake and I had to go back and edit this here. All right, let's try the next one here. Let's try beryllium. All right, beryllium on the periodic table is number 4. So let's start with what we know. It has 4 protons. Do the math, it has 5 neutrons and 4 electrons to start. We'll start the neutral atom. All right, so let's go and draw that there. 1, 2, 3, 4. So we have 4 electrons, 2 valence electrons. All right. We know that this atom right now is unhappy because he does not have a full outer energy level because that can hold 8. He only has 2. All right, let's set up our charges like I did last time over here. All right. So for my protons, I have 4 positive charges. For my electrons, I have 4 negative electrons. I'm going to put that separation between that first and second energy level here. All right, so for our first and second energy levels here, that second energy level can hold 8 electrons. It only has 2. As we said before, it has 2 options. It can either gain or lose electrons to get that full outer energy level. And so it's going to do easier. By easier, I mean whatever's the smaller number. It can either gain 6 more electrons. Seems kind of like a lot. Big number. It's a lot of work. Or it can lose 2 electrons. It's always going to do what's easier. By easier, I mean a smaller amount. In this case here, we are going to lose electrons. All right? So what we're basically doing is we're getting rid of these 2 electrons. They go bye-bye. Where they go? We'll talk about that later. All right, so what we just did is we lose 2 electrons. All right? Now that we've lost those 2 electrons, and you're saying, well, wait a moment, how can that be possible? That doesn't make any sense. That second energy level holds 8. Now you have 0. You're even further away. Well, these 2 electrons are gone. How many more electrons are in that energy level? That second energy level? 0. There's no electrons there. This second energy level is basically gone. Which means all that's left is that first energy level. How many electrons fit in the first energy level? How many are in there? All right, so basically what we did is we just kind of downsized and went down to the bottom level, which was already full. All right, it was just easier to kind of go down than it was to get to build back up. All right, so we lost those 2 electrons. We can do kind of the math version, or we can cancel out protons and electrons. I have 4 positives, which is basically positive 4. Or 2 negatives, which gives it a charge of -2. All right. I am now more positive than I am negative. Notice, I did not add protons. After I'm drawing these, I'm not adding protons. All right. What I am doing, though, is taking away and adding electrons. All right. So I can cancel out. Protons and neutrons can cancel out those charges. I am now more positive than I am negative. So what I've just created, since I gained or lost electrons, created an ion. What we have here is a beryllium ion. In this case here, it would be Be, positive 2, and -2 together make positive 2. All right? Or +2 beryllium ion. Right? This one was called an anion because it's a negative ion. This one is called a cation. And it sounds stupid, but the easiest way to remember this, again, I know it sounds silly, but it's a way that really helps. Cations. All right? Cations are positive. Like cat's paws. Cat ions are positive. You think that sounds really stupid, and it kind of does, but it's going to make you remember it because you all joke, and then I look over in a test and I see someone going, or they admit later, like, I actually did the positive things. The difference between a cation and an anion is cations are positive ions. So both of these are ions because they gained or lost electrons. This one's a positive ion or a negative ion. All right? It is all because we gained or lost electrons. It has to be electrons, not protons. Okay. All right. That's a lot of notes. I made a mistake in the middle and had to edit some of it, some of this video, but that was a lot there. All right. We do not gain or when we're forming ions, it's about changing the electrons. It's always going to be whatever's easier. It's got 2 choices. All right. Once you know those choices, you can either cancel out the charges or you can kind of do the math version. 7 positive charges, 10 negative, so -10. And then just kind of do the sum of those. Same thing over here. Positive 4, -2 makes positive 2. All right. Whew, that's a lot of work. All right, I'm going to stop this video because this is a long video. It's a lot of work to do on here. All right. This is just one way to show it, and we'll have to practice a lot in class because this is a tough one. All right. If you didn't understand it, I recommend watching it again. Once you do some practice, it starts to feel it out. You got to kind of go into the unknown, the good struggle, and figure that out. All right. Otherwise, thank you very much. Good luck, and may the science be with you.